Welcome to Summarize Science. Today we're looking at a breakthrough in making robots move more like us. Most robots use stiff motors, but researchers are trying to use artificial muscles for smoother, safer movement. These muscle-actuated robots are great because they are lightweight and flexible, meaning they won't hurt people if they bump into them. However, muscles are incredibly messy to program because they are unpredictable and change over time. For a long time, this made it almost impossible to train these robots in a computer simulation and have them work in the real world. This is called the sim-to-real gap, and it's one of the biggest hurdles in robotics. To solve this, a new tool called the Generalized Actuator Network, or GEAN, was created. Instead of trying to write complex math equations for every muscle fiber, it uses a neural network to learn the movement patterns. What's really clever is that this system only needs to see joint positions to learn, rather than requiring expensive force sensors. This makes the technology much more accessible and easier to apply to different types of robots. To test this, the researchers used a robot arm named PAMI-2, which is powered by pneumatic muscles. They trained the robot's brain entirely inside a computer simulation first. One of the tasks was a classic game of ball in a cup, which requires perfect timing and precision. When they moved the AI from the computer to the physical robot, it worked immediately without any extra training. This is known as zero-shot transfer, and it is a massive achievement for this kind of complex robot arm. They found that by using a small group, or ensemble, of neural networks, the robot became even more reliable. The AI learned to handle the friction and weird elastic properties of the tendons that pull the arm. This study shows that we don't need perfect physics models if we have smart enough learning algorithms. By comparing different training methods, they proved that focusing on position error was the key to success. The results showed a 90% success rate for simple reaching tasks and a 75% success rate for the ball in a cup game. Even when the ball was moving in ways the simulation didn't predict perfectly, the robot managed to catch it. To recap, this research successfully bridged the gap between virtual training and real-world execution for muscle-based robots. They used neural networks to handle the messy parts of physics that humans struggle to write code for. This means we can now train robots faster and more safely in simulations before they ever touch the real world. Looking forward, this could lead to more humanoid robots that move with the grace and safety of a living person. We might see these soft actuated robots working alongside humans in hospitals or homes. The ability to learn from simple data instead of complex sensors will likely accelerate the development of all kinds of bio-inspired machines. It marks a significant step toward robots that aren't just machines, but systems that can adapt to the physical world's complexities. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.